So, question 8. A census showed that 20% of all the married couples in a certain district had no children under the age of 16. So, first of all, probability, no children, is 0.2. 50% had one child, so the probability of one child, 0.5. And 30% had two or more children. 30% had two or more, 2 plus children. So, write this down as we go. We've got up to there. The census also showed that both the husband and the wife were in employment in 70% of couples having no child. So something is equal to 0.7. Let's read that again. The census also showed that both the husband and wife were employed in 70% where there was no child. So that's a probability of employment and no child was 70%. Let's read that again. The husband and wife were employed.
It was really weirdly worded.
Yeah, you read that as a given probability. Let's have a look at that one a minute. At the moment I'll stick with this and we'll go through and see what happens. Okay? In 30% of the couples having, so now we have probability of employed with one child, they're saying is 30%.
Is this all for the first part?
This is just extracting information from the first paragraph at the moment. And 10% having more than one child. Employed and more, that's 2 or plus children. So I think so far, just extracting the information, I've got that. Now, again, I thought there's lots of information there. I want to lay that out in a better way for me to understand. So, not quite a Venn diagram, but the other way we look at it sometimes. There are two things happening here. You're either employed or you're not employed. You either have no children, one children, or greater than or equal to 2 children. So those are the 6 categories we're looking at here. I know the no children altogether is 0.2 probability. One child altogether is 0.5 probability. That one there is 0.3 probability. Now this one here, this 0.7, that was the probability you are employed and you have no children. It's 0.7. Read that one again. Both the husband and the wife were in employment in 70% of the couples having no children. So this probability here, I think for here, which may answer your question here, 70% of these 0.2s, so in here 0.7 times by 0.2, 0.14 of the families are in employment with no children. So that is a slight changing of what I said up here. Okay, so I think you may be correct in saying that that was a given there. Okay, so I'll go back and I will change those. Okay, because the actual probability here, putting it together, of being employed with no children is those times together.
Wait, is that right? The 0.14?
The 0.14 is correct, yeah.
Cool.
So over here, we can do a similar thing. This one here is going to be 0.3 times by 0.5. This one is going to be that 0.1 times by that 0.3. So these are the AND probabilities coming in here. Now if you know that this column here is altogether 20%, and that's 14%, that's got to be 6%. 50% are here, well there's 15%, so that's got to be 35%. 30% are here, that's 3%, that has to be 27%. Now you've got your probabilities. You can hopefully go ahead and answer these questions. Part 1. If a married couple is chosen at random, calculate the probability that both the husband and wife are in employment. Doesn't say anything about the children, just employment. That's going to be this entire row. So add those together. 0.14, 0.15, 0.29, and that 0.03, 0.32. That will be the answer then to part A. Part B, if a married couple is chosen at random from those couples where both the husband and wife are in employment, so we are ignoring this bottom row now, we're just looking at the top row. So if a married couple is chosen at random while they are in employment, calculate the probability that a couple has at least one child under 16. At least one child under 16 is this one here or this one here. That's 0.15 or 0.03 out of all the parents, all the couples we're looking at, which is 0.32. That's out of how many people we're looking at altogether. And if you work that one out, you get an answer of 0.5625, and that is the answer for that one. It was those two bits there out of the entire row. And the final bit, for a particular purpose, a sociologist assigns scores to each married couple. I'll have to do this fairly quickly. The bell goes, can we just hang on a minute? The scores, right. The first of these is based on the number of children under 16, being 0 for a couple having no child, so they will get no points, and 1 otherwise. So these people over here will get 1 point because they have at least one child. The second score is whether they're in employment. 0 if they are in employment, and 1 if they're not in employment. Now we've got to add the scores together. So here, 0 and 0 gives a score of 0, 0 and 1 gives a score of 1, 0 and 1 gives a score of 1. Down here, 1 and 0 gives a score of 1, 1 and 1 gives a score of 2, 1 and 1 gives a score of 2. So these new numbers are the scores. Calculate the mean of the sum of the two scores for the married couples. This is like a question you would have had where you're finding the averages, with these are the frequencies. So you do the score times the probability, the score times the probability, the score times the probability for each of the 6 things, and then add them together. So what you're doing here is you're adding up for each one their score times by the probability. And if you do that, you get an answer of 1.48, which was the final answer. There were 13 marks for that question. Where they came from, I gave a mark for each of the probabilities in that table. You might not have them in the table, but they were worth a mark each.
So 6.
6 marks. A mark for part 1, 2 marks for part 2, and then 4 more marks for the end bit. 1 mark for getting the scores right, 1 mark for multiplying and adding, and 1 mark for the final answer. That gave it out of 13. I know the bell's going to go, but if we can just finish off by adding up your total marks.